And we're going to talk about animal products in our century, but you will see that I've actually changed that title to Sitting on a Time Bomb. I don't know why you guys are here, because I don't have very much good news for you in this lecture, and the next one's going to be even more exciting. But the good news is that if you have the stamina to stick around for the last lecture, then we can have some fun together. And we can try and find some solutions to the problems which I will highlight. In the meantime, sit down, fasten your seatbelts, and let's go. Animal products in our century. Well, I thought I'd just show you a brief shot or two from my university, because, if you lecture overseas, like, in the United States of America, for example, and you say that you are from Africa, then people have this image of grass huts, guns, lions, giraffes. We actually teach people in South Africa, and we have buildings. This is the student center of my particular university. It's quite a nice university. See, it has nice planes and nice buildings, sort of a little bit of an Eastern influence there, I think. And this is, of course, taken when the students weren't around, but we have thousands and thousands and thousands of students. So we are quite busy at this institute. But I'm not here to entertain you with pictures from South African universities. We're going to talk health issues, and we're going to talk about disease, its causes, how to prevent it, and what is different today to what it used to be like in the past. People always say to me, when you lecture on these issues, yeah, but my grandfather, he used to drink 40,000 bottles of whiskeys, ate so much meat per day, and this and that, and drank milk till it came out of his ears. And he lived to be 147, and we had to shoot him, get rid of him. Have you heard those stories? Yeah. That's the standard argument. Today, things are very different to what they were in Grandpa's day. And hopefully that will come out in the lectures. We're always hit with a statistic where people say, yes, but look how life expectancy has boomed in our age. In the old days, they used to die much earlier. Statistics are sometimes the biggest liars on the planet. Yes, life expectancy has gone up, average life expectancy. But most of that increase in life expectancy is as a consequence of licking the infant mortality problem. The medical world has solved this problem, and today, very few infants actually die in childbirth, and very few mothers actually die in childbirth. Whereas in the past, that statistic was very, very high. So if you take the mean of 0 and 80, then you get what? 40. And that's a very low life expectancy. Whereas if you cut that 0 right out and you take the mean of 50 and 75, then you still have a higher life expectancy than you had before, right? But in real terms, those that actually get there are actually dying at a younger age. In fact, we are more diseased today than we've ever been, probably in the history of the world, excepting when you take things like the Black Death or diseases like that. So if you look at age-specific incidence of disease in hundreds of the major cancers in the world, you will find that the big killers amongst males are pancreas, prostate, and colorectal cancer. And pancreas cancer has not such a very high incidence, but prostate cancer and colorectal cancer are in old age the number one cancers in men. Even young men these days are suffering more and more from prostate cancer, and more than they were in the past. If you take women, then you will find that colorectal cancer and breast cancer are the cancers that seem to cause the most problems, and mainly after menopause sets in. So the incidence becomes very high the older the people become. Now, they always used to say that it is linked to genetic circumstances. Well, today we all know that genes run in families. Is that right? But you know what also runs in families? Diets. Diets also run in families. Kids eat like their parents eat, who eat like their grandfathers used to eat. So if we have a look at the incidence of, let's say, colorectal cancer in Japan and in the United Kingdom, you will see that in the 60s, 1960s, the incidence of colorectal cancer was very high in a Western society with a Western-type high-fat diet. And over time, as fat consumption has increased slightly, but not too much since the 1960s, there's been a slight increase in relative terms in colorectal cancer. But look at Japan. In the 1960s, they ate like Japanese. And then as time went by, they used to eat more like the Western culture. Today, you get black blonels on every corner. I'm not using the trade name, as you noticed. And as a consequence, you can see that with this Western lifestyle that they have adopted, the incidence of colorectal cancer is now the same as it is in Western societies. Now, what does that tell you? It tells you that the problem doesn't lie with the genes, the problem lies with the diet. And more, we are beginning to understand that this is the case. Now, this is males. In females, you have exactly the same pattern, although the incidences are slightly lower, maybe because women tend to look after their appearance somewhat more than men seem to do, although that's also changing these days. So diets can determine your state of health, something which has been denied for many years. Well, here's an article by Dr. Kaizo Shida, Japanese Foundation for Prostate Research, says Japanese are eating more meat these days than in the past, so cases of fat-related diseases such as breast, colon, prostate cancer have increased. So they're starting to say it's in the diet. If you look at per capita meat consumption in the world, and you look at the incidence of colon cancer per 100,000, you will find that the nations that are very small meat eaters compared to the nations that are high meat eaters, and I told you last night already that New Zealand is numero uno, number one, they have the highest incidence of these cancers. So there is a very powerful relationship between meat consumption and degenerative disease. Now, we discussed last night in this lecture of the primary foods what the causes are for some of these problems. And you will remember that animal proteins are very rich in sulfur-containing amino acids, which, when metabolized, put a sulfate load on the organism, which in turn induces calciuresis, the loss of calcium, because when you have to pump out that sulfuric acid through the kidneys, you also have to buffer it, and you buffer it with calcium from the bone, and you lose that calcium through the bone. So osteoporosis is one of the problems. The next problem is that some of these compounds produce acidosis, which lowers your immune capacity. The natural T killer cells, which mop up cancer cells, they are affected. And then, of course, in our diet, the high fats and the free radicals that we spoke about are also elements that can induce carcinogenicity, cancer in the organism. Then the ring structures in the amino acids, the phenolics, they are associated with disease, particularly cancers as well of the colon, even skin cancer. And we spoke about the toxicity of ammonia and how it has to be detoxified to something slightly less toxic like urea. And that all these components, the more you have in your body, the more you have to fight on another level with these particular problems that you are putting into your body. Now, if you have a high meat diet, you also consume high concentrations of compounds such as these little guys here on the screen. You don't have to know the formula, no exam after this lecture. These are called heterocyclic amines. And if you look at them, these ring structures, they are all fairly similar, and they are known carcinogens. There are others as well, benzopurines and all kinds of these. For example, A-alpha-C here is known to be fairly carcinogenic. The methylated form, IQ, GLU-P2, all of these are problems. So when you look at the meat and what you are actually eating, you will find, for example, that broiled beef has 651 milligrams per 100 grams of micrograms per 100 grams of this A-alpha-C compound. And there are 180 micrograms in broiled chicken, and even some of this IQ stuff and the methylated forms and the methylated A-alpha-Cs, and even fish has these compounds in them. So the question is, how does this impact on your disease status? Well, obviously, the more you eat, the higher your risk category. That's just general. But there are compounds, again, which counteract these, certain compounds in vegetables and in grains and in fruits that can counteract these substances. So if you have a balanced diet, you can actually cope with some of these things without actually having too much of a problem. But when you start having an unbalanced lifestyle, then this becomes problematic. All right, there have been some major research projects investigating diets in the world and correlating particular diets with certain lifestyle diseases. So, for example, if you look at, this was a major study that was published in the American Journal of Clinical Nutrition, days per week meat consumed, and let's say, for example, diabetes, which is this one over here. You will see that if you have meat 7 times a week, then, well, you are having more than 4 times the relative risk of contracting that disease compared to someone who does not do it. There is a slight risk. Anything over 1 is problematic. For example, if you have 10 in a group and 10 in a group, 1 gets colon cancer, 1 gets colon cancer. 1 divided by 1 is 1. No difference between the groups, no risk. So 1 is no risk. The higher you go, the more problematic it becomes. If you look at colon cancer and prostate cancer, there's a slight correlation, so that if you have meat 7 times a week, then you also fall into a risk category of 1.5. Nothing to write home about, but it's there. If we look at women, of course, the diabetes is the same, so it's not on this graph. But if you look at ovarian cancer and coronary heart disease, slight risk. Now, 7 times a week, eating meat is not much. I used to eat 7 meat portions or meat meals within, well, 2 days. Because I used to have at least 3 meals with meat a day, every day. That would be 6 meat meals in 2 days. And if I take all the snacking in between, that easy makes up for another one. So I could get there in 2 days, no problem. Of course, generally speaking out there in the world, people eat meat every single day of their lives. So that's no problem to explain why we have such a high incidence of these diseases. Now, when you eat meat, I explained yesterday that the type of protein that you have in meat, which is a very compact protein, takes quite a while to digest. So once it gets into your stomach over here, the digestion process takes place, and in the duodenum, which is just thereafter, in this area over here, you have receptors which determine what actually comes through. And if there are large polypeptides coming through, too large, then the system is closed off and you have a longer stomach retention time. I'm going to deal with that in quite some detail in the next lecture. But let me ask you a question. People that say, I have tried vegetarianism, but it doesn't satisfy me, it doesn't fill me up. Is that a good argument against it, yes or no? You see, we have been conditioned to believe that satiety, feeling satisfied, is to be equated with a good meal. Have you noticed that? And if I don't feel satisfied but have to eat in an hour or so again, well, then I haven't had a good meal. It doesn't satisfy me. Question: how much absorption takes place in your stomach? None. Little bit of water, maybe a mineral or two, but of the molecules that you need for sustenance and life, none. So when do you actually start absorbing the stuff? Only when it's past this point and you have it right here in the intestine, right or wrong. So when you have a feeling of satiety, are you gaining any energy from the meal that you had? No. You will only gain the energy from the meal that you had once the satiety is gone, right or wrong. So just remember that for a while. So satiety is not an indicator of a good meal. If you put animal proteins into your stomach, depending on what type of protein it is, some are better, some are worse, you can increase the stomach retention time by 2, sometimes 3 hours over what normally is the case. So instead of having a stomach retention time with everything gone after about 3 hours, you can sit with it there for 6 hours. Which means that anything that is in there, because the stomach will respond to the macromolecules coming through and will close off the system until the job is properly done, the system will be informed, hold on to this stuff, and then you get fermentation in the carbohydrates setting in. And then instead of getting glucose as an end product of that process in the end, you get fatty acids, and that leads to an acid system. So any animal protein that you add in to your digestive system causes this particular problem. And of course, we also discussed that it needs a higher acidity because you have to get closer to the optimum of the enzyme pepsin. So you have all kinds of problems in the stomach leading to acid conditions. And that's why we are antacid junkies in this world. Have you noticed that? And I said before, no wild animal walks around or gets born with a bottle of antacids. Doesn't happen. Well, today, this is what they suggest as a good food substitute or a good indicator of food. And they have what they call the food pyramid, where in the bottom they have the grains and the cereals, then the fruits and the vegetables, then the meat and the poultry and the fish and the eggs and the nuts and all that sort of stuff, and the dairy products. And then up here they have the fats and the oils and the sweets, which is, it's a great advance on what they used to have. They used to have what they call the basic 4 diet, where they took your plate and they divided it into 4 chunks. And then they said, well, you need vegetables and fruits, meat, dairy, and then all the other bad stuff in equal proportions. At least they've moved up to a pyramid. Now, maybe in a couple of years' time, they will modify this pyramid to really fit what modern-day science is saying. Why are conditions so different today to what they were in Grandpa's day? One of the things is pollution and the problem of biological magnification. For example, the classic example of biological magnification is DDT in environments, in water, in the marine environment. So you can have DDT in the water at a concentration of 0.000003 parts per million. That's just about not there. As you go up one feeding level, trophic level, you have a concentration of 0.04. So that's 2 decimals compared to 1, 2, 3, 4, 5, 6 decimals. That means that we've had a 10,000 times, sometimes even 100,000 times concentration of a particular compound in the next feeding level. Then as you go up, they concentrate it further. As they go up, they concentrate it further. As they go up, they concentrate it further. So by the time you get to the top carnivores, you have concentrated those poisons over 1 million times, sometimes 10 million times. Now that's a major problem. In other words, what I'm saying to you is a farmer might be spraying his crops. Let's say he has a, let me say this in American, tomato crop. And he sprays his crops with a toxin at 10 parts per million. And let's say the wind takes some of the spray and spreads it over the countryside, and 30 miles away, some of this comes down onto a pasture at a concentration of not 10 parts per million, but let's say 3 millionths of a part per million. And then the grazers come and they eat and they eat and they eat every day. And through the process of biological magnification, they concentrate that, let's say, 100,000 times or 1 million times in some cases. It can be that that animal far removed has a higher concentration of those particular toxins in his meat and in the products of that animal than the plant that was sprayed directly. Then if you take the plant and you hold it under the water, because plants don't really do very well in absorbing organic toxins, which are mainly surface, you can wash a lot of that off. So a plant that was sprayed directly can have a lot less toxin in it than the animal product, which is a bit weird, but is a fact as we know it today. If you take the toxin tributyltin, which is a toxin that they put into the paint and paint it onto the ships of the large oil tankers. It's forbidden on small vessels because it is so highly toxic, to keep the barnacles off. That toxin occurs in the ocean at a concentration much lower than even the DDT. And yet when you come to a seal, the concentration in the tissues of the seal are 50 parts per million. 50. And it stores it in the fat. Now let's say there is a decline in the fish population, and for a day or two that seal doesn't get his normal quota of food. What does he rely on then to survive? His fat. So he mobilizes the fat, and as a consequence, the tributyltin concentration in his blood rises, and it knocks out his immune system. He gets pneumonia and he dies. And then you say, wow, the thing is undernourished, but you look at him, he's pretty fat. And you don't understand why. So, if we eat a lot of animal products, we sit with precisely this problem. You all know what happened to the pelican populations until they banned DDT. It caused calcium problems. But even worse than the general pollution and the increase of toxins in the animal products is what modern animal husbandry does to our food. That's modern farming techniques as employed by every single nation under the sun. Now this is my main research. This is my kick. This is my passion. I love this stuff. Here are some of my postgraduate students working on one of these huge experimental farms. We have quite a number of experimental farms in South Africa because it's cheaper for the nations like Europe, for example, to run their experiments in Africa before they implement their whatever they find in Europe because of the exchange rate. So these companies and these organizations do a lot of research for overseas institutes. But my students are permitted there because I work at a university that belongs to the previously disadvantaged society. And these are largely advantaged institutes. And then I say, I would like my students to come and work there, please. And then they say, well, we don't really have space. Oh, you don't want to work with the previously disadvantaged institutes? Oh, very well, very well. How many students have you got? What do you want to do? And I tell them the worst things that I want to do. They freak, but they're between a wall and a hard plank. They have no choice. I'm a little blackmailer sometimes. Well, they feed animals these days petrochemical waste. They feed them manure. They feed them carcass meal. They feed them blood meal. They feed them fish meal. They feed them any type of feed which will lower the input cost and which will supply high protein in the cheapest possible form. I thought I'd put that one up. I thought you would like it. Beeste vrek van voermengsel. Sounds so good. Don't you like that language? Een boer van Odendaal se Rus in die Vrystaat het meer as 500,000 rand se skade gelei deurdat 340 van sy voerkraalbeeste gevrek het. Oh, it sounds so good. Anyway, what it means is this farmer lost $500,000 worth of animals because of what he fed them. Now, what did he feed them? And then the article goes on to say that he fed them chicken manure, like every other sensible farmer does. You see, chicken manure is high in nitrogen compounds, the excretory compounds, and the bacteria can convert those compounds back to a nitrogen form that can be used by bacteria. And when the animal then digests the bacteria, it gets a high-grade protein. So you can use chicken manure to get a high-grade protein. Of course, you're putting a lot of acid in the animal, so you take a little bit of limestone and feed the animal limestone. So the diet of the cow now consists of chicken manure and rocks. Do you think that was the original diet of these animals? That's to buffer it, otherwise the animal dies, you see. And in this particular case, the ionophores, the growth stimulants that they used in the chicken, were what killed the animal. Now, remember biological magnification? Now, when these animals start looking a bit woozy, whoops, off to the market quickly before we have a problem. So that stuff, humans then ingest in their turn. Time magazine, June 14, 1999, fear in the food chain. Do you remember what happened in Belgium with the dioxin scare? This is what is happening more and more in the animal husbandry industry. Personally, I think the industry is horrendous. I think it is cruel. I think it is diabolical what they do to the animals. These are typical egg-laying cages. Here they are. These animals, they, of course, trim the beaks and have them sit in there. They live in there, the egg layers, for 1 year. They get fed their particular ration. And by the way, many industries, when they sell so-called free-range eggs, what they do is they add a little bit of carotene to the diet, and then the egg turns out orange rather than yellow, and it goes to the free-range people. You see? But it's the same type of chicken that we have over here. And then to save energy, they put 5 or 6 in a cage. Now, we've run a lot of experiments with these, as I've told you. We climb onto the bus, onto what the industry is doing in any case. We run along with the bus, and we try and show them that what they are doing is not only detrimental to the animal, but is detrimental to the consumer. This here is a broiler chicken that we put on the high-protein rations that they normally feed these animals. We just take their exact ration. This particular group, we used what the industry calls poultry byproduct. Have you heard of that? Well, let me tell you what poultry byproduct is. Poultry byproduct is the heads, the guts, the feet, and the feathers of the chickens that are left after they are slaughtered. All that stuff is then minced up, dried, pelleted, and mixed with grains and things and fed back to the chickens. So basically the chickens are cannibals. And feathers, of course, are indigestible. So you have a synthetic enzyme which is engineered in a laboratory which can digest the keratin in the feather, and you add that to the diet. Of course, it's such a potent enzyme, it also just about digests the whole chicken from the inside. So they have this gooey, tacky feces that they produce. And the high-protein diet is, of course, highly calciuretic to the animal. And so you will see that their legs are really deformed. Now, normally this doesn't bother them because they just sit anyway. They can't go anywhere. They've got nowhere to move. You know that it is so bad these days that sometimes you cannot even pick up the bones on an X-ray anymore because they are so decalcified. This is my Nigerian student. His name is Ogboko. I just love that name. And here is a typical setup of chickens and cows in typical stall conditions as they raise them in Europe and in many city areas. These animals are not allowed to lie down. They're not allowed to get up because that is wasteful energy. As I've said, the beaks are trimmed, the claws are trimmed. And because of the crowded conditions, we read more and more in the literature about health alert over chickens, salmonella outbreak in crops. And we hear of disasters in whole cities where, for example, last year in Hong Kong and those areas, they had to kill every single chicken. And they tell you, it's a precautionary measure. Ha! Nobody will kill every single chicken unless the fat is in the fire. Let me tell you that. Well, you just work it out. If you have, let's say, in a huge chicken farm, you have 1 million chickens. What would happen if disease came in and wiped them all out in one night? I don't know what a chicken costs in the United States. Help me out. What does it cost? One chicken. What does it cost? $3? All right. In other words, if you have 1 million chickens in your setup, that's a loss of $3 million in one night. Is that true? So, $3 million to lose just like that, I mean, that is horrendous. So, they're very sterile and they're very careful, and you have to walk through pools and sterilize yourself and all these types of things when you go in there. They have charts where they measure the death rate. They feed the chickens with rising bowls so that when a chicken that doesn't grow very well can't jump up because it's too crowded and they're too heavy, then they can't reach and then they die. So they have a proportion of deaths. And when that death rate increases beyond a certain quantity, then it's time to say, oh, well, maybe there's a problem coming here, harvest. And then you buy baby broilers, special price. Baby broilers probably would have been dead broilers tomorrow. Hard to swallow. You know, it's not just me saying this. The whole world is beginning to wake up. This was an article in Time magazine. Do you remember it? Hard to swallow, the dioxin scare, the toxins in the food. And then what about illegal drugs? This is Rida News. This is the chemical company that enables you to test for certain components. Here, for example, the illegal drug clenbuterol. The slaughter of 2,400 calves prohibited, read a headline in the Frankfurter Rundschau. A Dutch drug representative has been arrested on the farm, Münsterland, etc., etc. Okay, let's say, for argument's sake, you have 1,000 head of cattle. And let's say, for argument's sake, it costs $1 a day to feed them. How many dollars does it cost you per day to run your feedlot? $1,000. So how much would it cost you per month? $30,000. And you've calculated your profit margin and your input margin. And you know that from the starting point to the end product in your store activity, it'll take, let's say, 9 to 10 months to get them to a marketable size. Now, it's costing you $30 or $30,000 per month. And a guy comes along and he says, I got a drug for you. It's illegal, but your cattle will be on the market size 1 month earlier. How much is it worth? Well, $30,000, you wouldn't make a profit. What about half of that? Split the difference. $15,000 in the pocket, $15,000 to the illegal drug dealer, and both are happy. So we find in the world lots and lots and lots of illegal drugs that are very harmful to society. Doping in the cowshed. This is a Swiss magazine that is looking at this. These little calves over here are raised never to lie down, never to be able to move, because you see, cattle have to move their buttocks sideways in order to lie down. So you just narrow the cage and you can never lie down because you can't do that action, you see. I call this the T delta S factor. And delta H is the food that you supply to the animals. Delta F is the growth that you get out of that food. And T delta S is everything else that an animal needs. It needs to move, it needs to breathe, it needs to control its temperature, it reproduces, it does all those things. It crows, it makes a noise, whatever. Every single other activity is the T delta S factor. Now a farmer is interested in delta F. He wants to get maximum growth. Now if he wants to get this to be maximum, then what must he do to T delta S? He must make that as small as possible. So how do you achieve that? Well, number one, you make the temperature just right for the animal. Number two, you prevent him from moving around. You put 5 in a cage that takes 4. They sit there. They can't move. You take off their beaks, you take off their claws so that they cannot fight. And then you put them in sexes together so that they don't reproduce. And you cut every single activity down to an absolute minimum. And then the animal is just an automaton that has to grow as quickly as possible. The second thing that you want is you want your input costs, delta H, to be as low as possible. So how about that which other companies would throw away? The fishing industry, the heads, the guts, the tails that lie over there and first steam a while before they get cycled and then processed into fish meal or carcass meal or poultry byproduct or petrochemical waste or manure or any one of those. Anything to keep that cost down. So you feed the animal manure and you're surprised when you actually then eat assimilated manure. Well, these are pigs in these raising areas. That's how they are housed, that they cannot move. They sit in there their whole lives. Off the menu from early warnings that chickens were laying fewer eggs, the dioxin scandal grew to engulf Belgium's meat industry with a full ban on all poultry, beef and pork products. So this is something that is happening nationwide, worldwide. You know, we were worried about diseases like African porcine disease and swine's flu and things like that. Forget about that. We have got new diseases that boggle the mind. Malaysia, burying the bacon. Did human error help to spread a virus from pigs which causes encephalitis? Mania, dying of something similar caused by a virus this time, like the dementias caused by mad cow's disease? And how many pigs did they slaughter in Malaysia last year? Well, in southern Malaysia, they went in and they killed every single one. So more and more and more, we realize that animal products are dangerous. This was April 1999, 6,000 pig farmers, their mission to kill some 300,000 animals, Japanese encephalitis. A deadly disease is spreading amongst the farmers. Animal products today are not what they were in Grandpa's day. Pig transplants should be banned because there are specific viruses which are able to attack humans when they take valves, heart valves and things from pigs and transfer them. If they don't even want to take a valve to save a life, should we eat them? So maybe the pork just has to sort of, move a little bit off the table. Well, maybe we can create super animals by cloning. You remember? And we've done a great job with genetic selection. Chickens, by the way, the broiler chickens are raised with one object in mind, and that is meat production. So everything is geared to grow a chicken quickly. You know, in the past, it used to take 17.5 kilograms of feed to raise a chicken to 1.5 kilograms. That's a normal chicken I know I'm talking in kilograms, and I really should be talking in pounds, but the Americans are a little bit backwards as far as this is concerned, so maybe I can train you just to get up to speed here with a metric system. Just think normal chicken. To get a chicken from a chick to a normal chicken used to take 17.5 kilograms. In this industry, and by the way, it took 6 to 7 months to do that. Today in the industry, they use 3.5 kilograms, and they get it there in 6 weeks. 6 weeks, that chicken is out. Now, I'm not joking with you. If you go up to one of those chickens and you say, "Hello, Mr. Chicken," bah, it'll drop dead. It'll get a heart attack right there. Why? Because the internal organs, the heart, everything is totally undeveloped for this huge muscular body. So we are creating monsters. And what the health aspect of that meat is something that I am investigating with my students. I'm looking at every single parameter. We're still busy with that major project. By the way, cloning, we're finding that Dolly is well cloned, but she's aging at a rate that no other sheep ages. So, cloning's been around for years, they say. When you look at these scientists, they all look exactly the same. And I saw another little cartoon which I liked, was a bunch of scientists coming off the cloning and all looking exactly the same, and the one scientist saying to the other, "Oh, stop cloning around." Meat, the product of the injection, das Spritzenprodukt. Now let's have a look at what the World Health Organization defines as the world's deadliest scourges. What kills the most people? I'm not talking about diseases like heart attacks and cardiovascular disease and cancer and those. I'm talking about infectious diseases now. The number one killer in the world is acute respiratory infection. 4.3 million people. The number two killer in the world is diarrhea. And in fact, in Africa, diarrhea in little infants is the number one killer in Africa. Then comes tuberculosis, then hepatitis B, then malaria, measles, neonatal tetanus, and then AIDS. So the biggest killers, respiratory infection. Do you remember why those seals died? Because the compound that was released from the fat suppressed the immune system. Was that right? And the first infection that anyone gets as a consequence of that is normally respiratory disease. So a lot of these respiratory problems can be traced directly to the dinner table. Diarrhea, small proportion is caused by the water. Most of it is caused by infected animal products. TB, we know, is also transmitted by animal products, other ways as well, but largely animal products. So of the first three major killers in the world, the biggest concentration of them is caused by what people eat. And if you look at AIDS down there, the world is going ballistic about AIDS. You can mess with my sex life and you can modify it, but don't you dare touch my plate. That is the thinking of most people. In Africa, it is such a sad state of affairs. We have these little children coming in and they get tested with conductivity meters because there are no beds for them as they are dying like flies from diarrhea. And largely because of the types of diets that they are eating these days. Now let me show you something interesting. If we look at infectious diseases from bacteria, the number one infectious agent in North America, Canada, and in other areas, also in Africa, is actually a bacterium called Campylobacter. You all know about Salmonella, I presume. That's very commonly well known, but Campylobacter is even more prevalent. Now, if you look at the world incidences, these are cases UK figures, you will see that Campylobacter infections started increasing in the world here in the 80s. Salmonella started increasing exponentially in the world since the mid-80s, around about 1985. And since then, it's just gone up, 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 up. So if we go to a publication of that time, 1985, and we look at the veterinary record, and it says instead of being reserved for proper therapy, antibiotics are being administered increasingly to counter unsatisfactory husbandry practices. And so a study of that time showed, this was a Mexican study, that antibiotics found in randomly bought beef and chicken samples in the supermarket, you would find that none of the samples contained penicillin. Interesting, because they didn't use penicillin anymore, it didn't work so well. But if you check tetracycline, streptomycin, chloramphenicol, and gentamicin, groups of antibiotics, you will find that 86% of beef randomly bought in a supermarket would contain streptomycin. 40% would contain tetracycline. In chicken, it was even higher. 93% of any chicken sample randomly bought would contain streptomycin, and 97% would contain gentamicin. That's quite something. And what is more, you would find that in chickens, most probably you would find 3 different kinds of antibiotics present at any time. And in beef, most likely you would find 2 different types of antibiotics. Now, when all this started out, I became very interested, and I started giving lectures worldwide in Europe and in Africa, and I started saying that we are going to see infectious diseases that will hit this planet like a time bomb, and people will be dying like flies. And in Germany, they had a whole group of physicians who set up loudspeakers to shout me down and to say I'm talking rubbish. 4 years later, I went there again, and I said, now what do you say? Am I still talking rubbish? Deadly silence. Let me show you why. Antibiotic resistance in the bacteria from those Mexican studies showed that if you took the most likely infectious agents like E. coli or salmonella or any one of those, and you subjected those that came out of the industry to penicillin in either beef or chicken, you could find up to 100% resistance. That means you put penicillin on those bacteria, they don't even sneeze. That's if a bacterium could sneeze. Some of the others, we find very high resistance. But the chloramphenicals and the gentamicins in the 80s were still working okay. And if you look at the percentage resistance, you can see there was relatively high resistance. Some of them, like let's take salmonella, was on average at that time 50% resistant. And some of the others, like Salmonella epidermidis, was 90% resistant. So how can antibiotic resistance in bacteria affect you? Well, this is a 1991 newspaper article which said, mystery infection in hospital kills 7. Worldwide, we started to get hospital epidemics, which was very interesting. And Dr. Hamaldin said it was very worrying. We think it is probably started by a single carrier, but that could be anybody. We have visitors. The infection causes diarrhea, stomach cramps, nausea, fever, death. Now, what is the problem? Nowadays, we know what the problem is. Animal antibiotics threaten hospital epidemics. This was an article summarizing the literature in New Scientist magazine. You see, what happens is the following. Why are people in hospitals normally? Because they're sick, you see. But of course, there are a lot more people outside the hospitals that are sick. But in a hospital situation, you pick it up so nicely. Of course, that applies to the whole population, but you pick it up in a hospital. Now, you are sick in hospital, and when you are sick in a hospital, what is the most likely drug that you will be on? You will be on an antibiotic. Now, the antibiotic solves this particular problem that you have. Let's say you have an infection, a respiratory infection or whatever. You're on an antibiotic, and the antibiotic kills those bacteria. Does it also knock out some other bacteria in your body, yes or no? Sure. So your gut bacteria suffer. You don't kill everything, but you have fewer bacteria that are active and alive under that situation than you normally have, right or wrong? Okay. Now breakfast comes along. A nice soft-boiled egg and a glass of wholesome milk rich in calcium. Nothing wrong with it, and you eat it. But it comes out of the industry. So in that egg, there are bacteria, which are common to your own system as well, but they have something that your bacteria don't have. And what's that? They have become resistant because of the practice of feeding antibiotics to the animals. You know why they feed them? Well, number one, to prevent disease, they say, subtherapeutic doses. But number two, they feed it to them because it acts as a growth stimulant. And you know why it acts as a growth stimulant? Because the body spends energy on defense. Now it has an antibiotic which takes over the defense, and it doesn't have to spend that energy, therefore it can grow faster. You understand? So it's financially advantageous to feed the animals antibiotics. Now that egg or that glass of milk, and by the way, the pasteurization process is very quick and kills largely all the lactobacteria, but the bad guys somehow seem to survive. Now, there might be very few in there, but by the time it actually gets to you, seeing that all the other bacteria have been knocked out by pasteurization, those bacteria are actually having fun in that milk. So now you're drinking the milk and you're having this thing, and they come into the body, and the bacteria look around and say, hey, where's everybody? And what's the matter with you? Why are you looking so weak? Get out the way. And they start reproducing. And they take over. And now you have, in addition to what you had before, diarrhea. So the doctor comes around and he says, not feeling so well? No, I've got terrible stomach cramps and diarrhea. No problem. We'll put you on another antibiotic prescription. Another antibiotic. Unfortunately, that antibiotic was also used in the industry. So the bacteria, if they could, say, pfft. And eventually, if you're not strong enough, if you're an infant, or if you're old, or if you're sick, or if you're very frail, and you haven't got the stamina to do it yourself, what happens to you? You die. So the use of subtherapeutic doses of antibiotics is a major problem. So let's have a look at some of the scientific literature. A smoking gun, the killer within. And then the children are dying. An epidemic of food poisoning is only the latest Japanese disaster. Why can't the government cope? And the Minister of Health goes around as the little kids are lying there and they are dying by their hundreds. Devastating earthquake, and now this terrible attack. 8,500 of them fall sick in Osaka. The World Health Organization says unprecedented in modern history. See, Grandpa never dealt with anything like this. Oh yeah, what was the culprit? It was a strain of E. coli bacterium 0157.H7. Now, they continue to say, children complained of vomiting and diarrhea. Doctors, assuming they were treating simple food poisoning, gave them antibiotics and sent most of them home. But within days, thousands of kids with the same symptoms were streaming into the hospitals. What was happening here? You see, when I said in the 90s already, early 90s, we are going to see epidemics on this planet like you have never witnessed. Nobody wanted to believe me. In fact, when I tried to publish this stuff, they wouldn't even publish it. But nowadays, they are looking up and they are taking our publications. You know, the Spiegel talks about deadly eggs. Deadly eggs. Are eggs as safe as they should be? You can see they've got them packed in a coffin over there. Days per week egg consumed and the relative risk of disease, prostate cancer and colon cancer. You'll see egg consumption has a correlation of 1.5. So if you have 7 eggs per week, that's not difficult. There are so many hidden eggs in pancakes and cookies and cakes and whatever that you buy, that you can get to 7 eggs very easily without eating even an egg a day. You would never even notice it. Now, 1.5 might not seem very high, but what was it for meat consumption? 1.5. So 1.5 plus 1.5 for eating eggs and meat, what will it be then? Well, you would think it would be 3, but there's a little rule in science which says relative risk is always more than additive. So it must be around about 4 point something. Egg consumption in women is very highly correlated to ovarian cancer. In fact, this is the one cancer where ovo-lacto-vegetarians don't have an advantage over the general population. Generally, vegetarians have lower cancer rates than non-vegetarians, but ovo-lacto-vegetarians seem to have the same incidence of ovarian cancer. Not very high, but it's there. I just thought I'd show you that one again. It doesn't matter where you are, whether you are in Africa. This is contamination of chicken eggs, spreads countrywide, superbugs. And this is from the journal Science, and they are giving the sources of infectious epidemics from Campylobacter, Salmonella, E. coli, the one that caused the Japanese disaster, Listeria, bad guy. It occurs in soft cheeses and things like that, and in fish. That one is a deadly, deadly fellow. It causes transient blindness, stillbirth. Most people that get it get violently ill. Many, many die. We've had 12 outbreaks in Soweto alone, and a number of outbreaks in Switzerland. In one of the recent ones, some 186 people died in this highly sophisticated, medically superb country. Now, what are the sources? Poultry, raw milk, untreated water. Eggs, poultry, meat products, raw product, ground beef, raw milk, ready-to-eat foods, deli food, seafood, crustaceans. Largely, you'll find it's always the animal products. So we did a little test. We went and we did an experiment, which is, by the way, published in Letters to Microbiology, one of the top micro journals in the world. And we decided we were going to check out antibiotic resistance and prove once and for all that it comes from the farmers. Because the farming industry was saying, it's not from us, it's not from us, no, 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 it's the medical world that's responsible with all their antibiotics. Have you heard that story? Well, let me show you. We went and we tested bacteria, let's say Staphylococcus, this is the one that causes the deaths in hospitals. And we tested resistance to tetracycline, streptomycin, gentamicin, oxalin. Vancomycin is the only drug that can still knock out Staphylococcus in these hospital epidemics. The only one that still works. And methicillin. And that's the ones we tested. 2 of them are penicillin derivatives. And we checked it at the abattoir, and we checked it at the retailer. So in the store where you would buy it. And this is what we got. 90.5% resistance at the abattoir as opposed to 79.5% resistance at the retailer. If you take oxalin, 93% resistance at the abattoir, 72% resistance at the retailer. If you take enterobacteria, 100% resistance at the abattoir, 54% resistance at the retailer. And that was a general trend. Total aerobic, 90% resistance at the abattoir, 34.8% resistance at the retailer. That proves that it comes from the farm. Let me explain the model behind it. The farmer delivers it to the abattoir, right? And there it comes from the farm. We tested, it has a very high resistance. Then the meat goes to the retailer. He handles it and he works with it and he adds bacteria to it. From his work and from the environment and from his hands and from his ears or whatever he does, adds bacteria to it. But the bacteria that he is adding, if they were the problem in the resistance, then the resistance would actually go up when you go to the retailer. The fact that the resistance comes down means that he's adding what type of bacteria? Non-resistant bacteria. So he's diluting the resistance. So we proved that it comes from the farm. This caused a major stir, and the meat industry was ready to me. An inedible beef stew, the United States just managed to recall last year tons and tons of beef before the same problem has hit Japan, was to happen, the killers all around, return of the hot zone, Ebola, ostrich meat and the Ebola virus scare, bacteria begin to outwit antibiotics, meat-eating, flesh-eating bugs, malaria is back with a vengeance. Our drugs have created a new generation of superbugs. And you know, the only way to avoid some of these things is not to eat the things that are infected. All right, enough about the farming industry. Thank heaven there's still fish around that I can eat. Ah, what a relief. How safe is seafood these days? Well, here is a nice Malawi market. I took this one because it looked so neat with all the flies sitting on that fish. I have this mean streak in me. That one looks slightly better, doesn't it? Looks more appetizing. Well, we read about beaches hit by health ban, the poisoned Amazon, cholera makes a comeback. Cholera is carried largely in fish in Argentina when they had that cholera outbreak. The minister appeared on television and said, fish is perfectly safe. And when the people started dying like flies, he lost his job. I told you the story about the seals and how they are concentrating the toxins as we go up the food level, and how thousands and thousands of seals are being washed up on the beaches of the world, sometimes in 1 month, off the Atlantic coast in Africa where there's no industry, nothing pouring into those oceans. Along the coast of Namibia, there's just desert there. 10,000 seals, 1 month, boom, just like that. Something is seriously wrong. If you take the far-off regions, like here, the northern Arctic Circle, you know, people always say, oh, I don't eat coastal fish, I only eat the deep water variety. Well, I have news for you. How far away from industry can you be than in the Arctic Circle? And today we know that the Inuits have the highest rate of osteoporosis and degenerative disease, and have incredibly high concentrations of PCBs and pesticides and other things in their tissues as a consequence of the pollution and the accumulation of toxins up the food chain. They eat, of course, fish a lot, and they also eat seals, which have concentrated these toxins. Today we know that parasites in fish are increasing at an alarming rate. New scientists, parasites for supper. We find fish more and more are being caught with tumors in them, particularly internal tumors, liver tumors, which you don't see in the final product. I was on a boat, you can't see this very well, and there was a school of fish around the boat. This was in Portugal. Every single one of those fish had a tumor on its back. It was absolutely horrendous. Mystery killer stalks Australian waters. New parasites in fish are appearing at an alarming rate. In Africa, the most common fish, the one that feeds the masses, is hake. And in hake, they now have a new parasites which cause agonia. That means they don't even develop sex organs. I had to catch one of those. If you look at the world fishing markets, you'll see that they're rapidly on a decline everywhere in the world. No matter where you go, they're on a decline. Why? Because they're being overfished. Now, think about this logically. Just shake your heads to get some logic back in there. You ready? Think about this. If mankind is catching the fish largely, then the fish that remain over, the few that are left, should they have an abundant food supply or not? Logically, yes, because you've taken away a lot of the competition, right? So you would expect that the fish, the fewer fish that are there, are at least getting a good basis from their environment. But you take the fish and you have a look at what happened over the last decades, you will find that in the 80s, you could, on a good year, from 1 ton of fish meal, extract 35% oil. So of every ton of fish meal, 35% of it was fish oil. And the oil and the fat in the fish is an indication of how much energy that animal has stored. If you were to take this graph back, I couldn't fit it on, to the 1950s, you will find that fish had on average 50% oil in a ton. And in the 90s, you will find that you only have 8% oil. What's happening? Well, they say that the ratio and the type of fish is changing, but that doesn't account for that high percentage drop. The fish do not have enough energy stored in them because of some environmental problem. Now, if you take the same time period and you take the anchovy population, you will find that since the mid-80s, before the mid-80s there was nothing, but since the mid-80s, the fish are developing what we call atresia. They develop the eggs, and they are about to spawn the eggs, but they don't have enough reserves in them, not enough stored energy to actually spawn those eggs. So they resorb them to stay alive themselves. That's called atresia. Now, there's something mighty wrong when fish are going into atresia and they don't have energy stores in them. I'm always a little bit worried when they come out already fried. So, the bottom line is that fish, particularly those of the higher trophic levels like the tunas and those types of fish that are so very popular, have very high levels of accumulated toxins in them and are perhaps not as healthy as you might wish them to be, even when they come from a deep water source. It makes no difference. And then, of course, let's just briefly run through this prion craze in the world and see whether it's really over. Mad Brains, the prion heresy, this man was the one who said that mad cow's disease comes from a prion, which is a protein and not a bacterium or a virus or anything like that. And of course, it was decried a heresy. It was moronic to think that a protein can cause disease. Today we know that this protein indeed can cause disease. Now, prions normally, a normal prion has this helical structure, this little ring structure. Prions are proteins that occur in the brain. And when mad cow's disease started striking in the world, scientists went on a rush to find out what was going on. Now, normally, normal prions, by their millions and millions, are located between, like these blue ones over here, between the nerve cells. And occasionally, when a prion becomes abnormal, in other words, it loses its ring structure and makes a sheet of protein. Now remember, this is a very tiny protein, so small and compact you cannot digest it. So small and compact it's not destroyed by boiling or cooking or heating, even pressure cooking, nothing will destroy it. And when you absorb it as is. Now, they found that when an abnormal prion touches a normal prion, like a domino effect, tick, 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 the normal one becomes abnormal. And when it is abnormal, it doesn't lie between the nerve cells, but actually sticks on the nerve cell, like this. And eventually, that nerve cell dies. And it leaves a pinhole, and then the whole brain gets full of pinholes, and in the end, it looks like a sponge. That's why it's called spongiform disease, spongy. Encephalitis within the head. Cow, bovine spongiform encephalitis. Cows with spongy brains. That's what it means. Scientists must always have these fancy names for simple things. And Der Spiegel in Germany published John Major over there, where he holds his hand and says, not to worry, British beef is perfectly safe. Don't worry about it, folks. Don't worry about it. And the caption was, Die Menschen drehen durch, the people are going crazy. And then they published this little caption of him. I have eaten beef all my life, and I can assure you it has never really harmed. So not even the public was believing him anymore. Now, if you look at the epidemic of mad cow's disease, you'll see, isn't it exciting that everything starts in the mid-80s? I'm getting a bit nervous about the mid-80s already. The first signs were there in mid-80s when there were 15 cases of mad cow's disease. By 1987, there were 663 identified cases of mad cow's disease. By 1992, there were 37,000 confirmed cases of BSE. Now, that's what was sent to the lab. which means that 1 or 2 cattle from a herd was sent to the lab, which means that the whole industry, every single one in the whole country could have been contaminated. And eventually they decided, of course, that every single one of them had to be put down. Wow. Can you imagine how many billions and billions and billions that cost to put a whole industry down? But that's not my point here. By 1996, they had it under control and they said, everything's fine. Everything's fine. Don't worry about it. 1992, they had piles and piles of dead animals. Now, why did it increase like this? You see, they thought that the prion was, well, they didn't know about the prion by 1992. They only started finding out about prions here in the 1996 area. So they were mightily confused. They didn't know what was going on. The cattle were dying, so they weren't fit for human consumption. So what did they do with them? They made carcass meal out of them or pets' food out of them. So they were fed to the pets. And they said, you know, you can never ever get it from eating. But the cats got mad cow's disease. The cats had to be put out. They were feeding carcass meal to fish, to carp farms. And the fish went, got mad fish disease. I guess you can't call it mad cow's disease, right? And they were feeding it back to the cattle. And of course, the animals were consuming the prions, and the prions were causing a domino effect. So more and more and more and more cattle developed the problem. So, since 1992, British export of beef to Europe skyrocketed. There's the figure in millions of tons. Up it went. 1992 was the heyday of the problem. Is that right? So by 1995, exports had reached phenomenal rates. Britain was exporting its meat to the world. In Africa, in South Africa, in Australia, in Europe, in Eastern Europe, you name it. Beef by the ton was going into the stomachs of the human population. But that is just the beef export. What do you think happened to the mountains of carcass meal? Where did that go? Well, that was exported as well, all around the world. Nice, cheap carcass meal from Britain, compliments of the Prion Society. So they exported their problem worldwide. And they said, you cannot get it from your diet. Well, by 1994, they already knew that mad cow's disease was passing on to cats. That was, and just a newspaper article, London alarm is growing in some quarters here where the admission by Britain's Minister of Agriculture that mad cow's disease has apparently crossed the species barrier to cats. And still they were exporting it. And they said, don't worry, you will not get it until you are a ripe old age. It takes a long time to develop. You will be 147 before you even know that you have it. And by that time you're dead, so don't worry about it. And the young people started getting it. 20-year-olds. Then little kids started getting it. These are 3 children that died of mad cow's disease. Oops, there goes that theory. You see how slow science is to react when it comes to a money industry? So they said, let's burn the animals. We cannot use them for carcass meal. We cannot use them even for human consumption. So they burnt them on the fields. And the cows came and ate the grass, and they got mad cow's disease. Oops. So not even that destroyed it. So then they had to incinerate it under high temperatures like this in incinerators, and that stopped the problem. Now, everything's under control, folks. Don't worry about a thing. And they were saying, if you eat the meat, you're all right. You see, because meat, which is the blue portion here, all the blue portion, has less than 10 prions per gram. Less than 10 prions per gram. So they exported just the meat, and they said, don't eat it off the bone. If you look at the yellow portion, which is the intestine and the glands, that contains 1 million prions per gram. How do you make sausage? What do you put it in? You put it into the intestines. That was one problem. Of course, the main problem was the brain and the spinal cord, which contained 1 billion prions per gram. Then bone itself, the marrow, also contained 1 million prions per gram. Now, that is a picture of London's premier beef market, which is Smithfield Market. And you can see the carcasses hanging over there. Can you see them? Now, how do they prepare cattle or when they take the meat off the bone? The first thing you do is you take this animal and you put it through a bandsaw. And I think I can do this quite well. You go, and then you got 2 halves. Is that right? Now that bandsaw, where does it go through? It goes right through the center, through the marrow. So it's going through 1 billion prions per gram. And as it goes, does it smear it on the meat, yes or no? Absolutely. So where's this nonsense come from that you won't get prions if you eat the meat? And then Europe, 50,000 animals confirmed with BSE in Germany and in Switzerland. And you never heard anything. It was a purely British problem. Who's going to pay for this grave of billions? Confirmed it was BSE. By 1997, they had BSE all over Europe. France said, we only sell French beef. Spain said, we only sell Spanish beef. And they printed, like deadly eggs, the Spiegel was saying, deadly meat. Suspect, United States. The beast that made British roasts great falls under official indictment as the likely transmitter of a fatal human disease. Can this disease spread to the United States? Could mad cow's disease come here? No chance. Forget it. Mad cow's disease scary in South Africa. Now let's have a look at what the scientists in the world are saying today. This is accumulated BSE cases reported worldwide, excluding Britain. And the question there is the tip of the iceberg. And look at it there. Since our time, the graph is an exponential. Would you agree that if it took, let's say, 15, 20 years to develop in the UK, and they've exported it to the rest of the world, that within the near future we might see a worldwide outbreak? Wow. Tests could pin down mad sheep risk. It's not only mad cows. We now have mad cats. We have mad sheep. We have mad fish. We have mad beef. We have mad everything. The world's going bonkers. The doctors at VA Hospital in Pennsylvania autopsied 54 demented patients and discovered that 5.5% had died of Creutzfeldt-Jakob disease. A rate of occurrence about 1,000 times higher than expected. Neurologica, 1989. Oops. Creutzfeldt-Jakob disease has apparently been transmitted by cornea transplants. Scientific American, 1995. Ample justification exists for considering a similar pathogenesis for Alzheimer's disease and the spongiform virus encephalopathies. Annals of the New York Academy of Sciences, 1982. Isn't the problem escalating? Perhaps this lifestyle will have to be modified. So we see animal products in our day are very different to what they were in Grandpa's day. And by the way, let me give you an interesting statistic. In 1910, the average American got 30% of his protein needs from animal products. Today, it is a staggering 70% and up. So, in those last decades, no matter what they spin, it is a fact that more and more refined food and more animal product is being consumed by this very society and every other Western governed society in the world. And the only safety that we really have against all these things, and there's only one method that can cure the problem, and that is abstinence. Problem is, where do we get our proteins from, and our energy from, and all our needs from? So stick around, take a break, have a nice hamburger in the back there, someone, BSE free, and relax for a while, come back and enjoy the next devastating exhibition over here. Thank you.